Okay, apparently the last video didn't have any sound, so let's try this again. Section 4.2, Structure of the Nuclear Atom. So, if we want to look at the bones inside of a hand or our teeth, we can use an X-ray. We don't have that ability with atoms, and so we have to use various experiments to determine the structure of the atom. So, we should know the three types or kinds of subatomic particles. Much of Dalton's theory is accepted today. One important change, however, is that atoms are known to be divisible. They can be broken down into even smaller parts. We call these parts subatomic particles. And you already know the three particles. Those are electrons, protons, and neutrons. And electrons were discovered by J.J. Thomson in 1897. You do not need to know the year. You do need to know the physicist, his name, and that electrons are negatively charged subatomic particles. You also need to know the experiment that he used to discover those, and we'll discuss that. So he performed experiments using an electric current through a gas that's in a tube at low pressure. He sealed the gas. He fitted both ends with a disc called an electrode, and then he put a source of electricity to those electrodes, causing current to flow through the gas. So here's a picture of that video. It's got a little star on this slide, means it must be important. And so we have our tube here filled with a gas. We actually have a cathode ray tube here, and I can show you when we get back in class. Here are the two metal discs, which are electrodes attached to a wire that's attached to a voltage source. The current flows through the gas, and it causes this glowing ray to appear. So, the beam was called a cathode ray, and it traveled from the cathode to the anode. So we have the cathode here on the left, and the anode is here on the right. And when a magnet or some kind of a positive or negative plate was put on either side, it was found that the ray was deflected towards the positive plate and away from the negative plate. So he knew that the positive charges attracted negative charges, or like charges would repel. So he proposed or hypothesized that the cathode ray was a stream of tiny negatively charged particles, and these were moving at high speed. He called these particles corpuscles. You don't have to know that name. They were later called electrons. And we can do this kind of an experiment at home, here in class next week. And so even a magnet will deflect that ray towards the magnet if you're using the positive end. He concluded that electrons are components of all atoms because it didn't matter what gas he put within the tube, he got the same result. So after this, Millikan came along and he carried out some experiments to find the quantity of the electron's charge. And from his data, he found that each oil droplet was a multiple of 1.6 times 10 to the negative 19th coulombs. No, you don't need to know that number. And meaning this must be the charge on the electron. This experiment was called the Millikan's oil drop experiment, and it discovered the charge on the electron. Also a star on this slide. So, using the charge to mass ratio from Thomson, he was able to calculate the electron's mass. So it not only gave us the charge, but it also gave us the mass of the electron. Millikan's value for the charge and the mass were similar to those that are accepted today. So electron has a unit of 1 unit negative charge, and it has a mass of about 1 divided by 1,840, the mass of one hydrogen atom, and a hydrogen atom just has one proton. So, if cathode rays are electrons given off by the atoms, what remains of the atoms that have lost the electrons? For example, hydrogen atom, the lightest atom, loses an electron. What is left over? And you can think of this problem using 4 simple ideas about matter and electric charges. Atoms have no electric charge. They are neutral. Electric charges are carried by particles of matter. Electric charges always exist in whole number multiples of a basic unit. That is, there's no fraction of a charge. And when a given number of negatively charged particles combine with an equal number of positive particles, the electrical neutral particle is formed. So, it follows that the particle with 1 unit of positive charge should remain when the typical hydrogen atom loses an electron. So I am going to stop here, and we will carry on with the second part of this video in just a minute. Thanks for listening.